I'm Julia, I represent Chernobyl MPP International Department, and I will present you the information about the shelter, about the works which are in progress nowadays at the site, and about plans which are connected with their new project, the most prominent one at the shelter site, the project on the new safe confinement construction and commissioning. So the shelter, yes, sarcophagus, dark gray structure, the facility which was constructed over the destroyed reactor 4 after the accident in 1986. Yeah. The construction of it was started in May 1986, several weeks after the accident. There was no time for any design activity. All the technical decisions were taken here at the site. Yeah. The task was as sooner as possible to construct a protection, to make shielding, yeah, on the way of radioactive emissions, which were extremely massive, extremely powerful, especially within the first 10 days after the accident. That was the active phase of the accident. And works within these first hours, first days, first weeks at the site, they were extremely dose-taking. Just imagine that people, by the by, more than 90,000 all in all, were involved in the works here at the site. First of all, of course, these were Chernobyl MPP workers, operational personnel, firefighters. Yes, they were the first at the place of the explosion. And just these very people, they realized perfectly well where they worked, in what environment, risky environment they worked. They realized the risks for themselves, for their health, yeah, for their life. But they just did their job. You see? You know that more than 600,000 people, 600,000, got a status of a liquidator after the accident. These are people who were involved in the works here at the Chernobyl site and in a 30-kilometer area, in the exclusion area. They got a status of a liquidator. Yeah. And nowadays, when we mark the 29th anniversary, this April we will mark the 29th anniversary since the accident. So each year, especially in April days, these very people, the participants of those events, they usually come here. Maybe it is the only chance for them to greet each other, to talk to each other, to recall the events of those days, to recall their friends, their colleagues. Well, they were young. These 29 years ago, they were young. Yeah, it was their youth, the days of their youth. But you see, each year, the number of these very people is less and less. You see, a lot of money was spent. Yeah, a lot of 29 years ago. And nowadays, a lot of money is spent for all these works, yeah, here at the Chernobyl site. But the highest price which we paid, yeah, it was the price of human's life. 29 years ago, we paid a very high price. That was the price of human's life. Yeah. I would like you to have a look at this very model. Yeah, the model Уже все открыли, уже все фотографировали. So, this very model, well, it illustrates the environment inside the destroyed reactor and destroyed unit nowadays, 29 years after. You see, you can see here the reactor itself, RBMK type reactor. You can see the reactor core, which was completely destroyed. Yeah. All the safety systems, safety barriers, they were destroyed. Yeah. You can see an upper reactor plate. It's biological shield of RBMK type reactor. Yeah. The experts nowadays, they call it, maybe you, do you know how they call this very structure? Yeah. In Russian, it is petachok, 5 kopecks. Yeah, 5 kopecks, yeah, petachok, yeah. So this very structure, it stood like this, yeah. Technological channels, these are technological channels, 1,661 technological channels, yes. They were inside as a result of the explosion, yeah. This very structure, which weighs more than 2,000 tons, this very structure jumped almost 30 meters high, destroying the roof, and then it stood back. Yeah. Nowadays, it is fixed in that very position. Yeah. 2,000 tons, just imagine what was the power, what was the capacity of the explosion. Yeah. As a result of the explosion, a very large, a huge area was contaminated. Just imagine the area of Chernobyl site itself, the area of Ukraine, Belarus, yeah. Russian Federation, Eastern Europe, Western Europe, Scandinavian countries, totally about 200,000 square kilometers were contaminated as a result of the explosion here at the Chernobyl site. If we talk about the risks of the destroyed reactor, 29 years have passed, but the risks are still here. I'm talking about, first of all, the so-called fuel-containing masses, yeah, all those materials which generated, yeah, you know that fuel, the reactor was loaded completely, 200 tons of uranium. Yeah, reactor was loaded completely. So uranium under very high temperature melted. Yeah, it was mixed with all those materials which were dropped inside from helicopters. Yeah, what was the primary task just after the accident? To stop the chain reaction. Yeah, to localize fire. Everything was done for it. So tons and tons, cubic meters, well, thousands and thousands of cubic meters of different materials such as sand, soil, lead, boric acid, dolomite, well, were dropped inside from helicopter, yeah, to stop the chain reaction, to localize fire. And all these materials, plus concrete structures, plus steel structures, were mixed and melted. Yeah. And such materials as fuel-containing masses generated. There was a risk that all those materials, being extremely hot, the temperature came to 2,000 degrees above 0 Celsius. Yeah, fuel melted. All those materials the risk was that all those materials would destroy the foundation, and they would get into the soil and groundwaters. The consequences of the accident in such a case might be even more serious if we have now. You see? That's why the decision was taken that time to construct a tunnel under reactor 4 building, to concrete it, and to fill it with liquid nitrogen, to cool, to stop all those movement, all these moving fuel-containing masses. At the model, it is shown by the orange color, But you see, these very materials, they stopped themselves. I don't know, fortunately or unfortunately. You see, they stopped in under-reactor rooms themselves. Nowadays, we have 200 tons of fuel-containing masses. We have some pictures which illustrate what I'm talking about. Yes, here. You can see all those materials which are concentrated inside. This is one of the largest heaps, one of the largest accumulations inside, which is called an elephant foot, world-known elephant foot. It weighs approximately 80 tons, 80 tons, but by the condition of fuel-containing masses nowadays is quite different as it was 29 years ago, 20 years ago. Nowadays, all those materials start deteriorating. They start cracking, bursting, peeling, due to this destructive process. A lot of dust, fine dispersed radioactive dust generates. Also, one of the risks, shelter initially being not sealed, all those structures, these dark gray structures, in 1986, they were just placed. They were positioned on unit structures which were not destroyed. And nothing could be changed. Why so? You see, the levels of radiation in which people work, under which people work, were extremely high. Just imagine that northern area, nowadays a cascade wall, northern area. The level of gamma in this very area after the accident was 2,000 rem per hour, 2,000 Röntgen per hour. The level of roof nowadays, it's 75 meters high. After the accident, in 1986-87, the level of gamma came to 2, 3, 4,000 rem per hour. People could work minutes per day, 2, 3, 5 minutes. They constantly replaced each other. The rotation of a personnel was extremely high. For these minutes, people got a yearly dose. They were extremely highly exposed. That's why nothing could be changed. The construction, by the way, of the sarcophagus over the destroyed reactor lasted only 6 months. Just imagine. Do you know any other project nowadays, such unique project, the project which was completed in an extremely risky environment, which was completed within only 6 months? I personally know. Yeah. So initially, the shelter, it was not sealed. The total area of openings when it was completed in November 1986 was about 1,000 square meters. And within, let us say, 15 years after the accident, there was a risk of local collapse of the shelter structures. I'm not talking about all the facility. I'm talking about risk of local collapse. There were very large gaps, very large openings, yeah, in the shelter structures. You can see them at this very picture. That is the condition of the northern area. Cascade wall and the plates of the northern area. There were very large gaps. I'm talking about the risks of dust release outside. Yeah? We have special system, which is called the so-called dust suppression system. It is shown at the model. Yeah? This very system, This very system is shown at the model, dust suppression system. You can see sprayers, yes, sprayers. We spray special submixture to fix dust on surfaces, yeah, to suppress dust, to prevent its release outside. But in any case, this very system, dust suppression system, it covers only the central hall, not northern area, not southern area. Only local dust suppression was possible and is possible in the areas where people worked. For example, within stabilization activity. I have already mentioned the risk of local collapse. Let me show you some other pictures, which illustrate the condition of the shelter roof. These pictures were taken some 6-7 years ago. That was the condition of the shelter roof. Yeah. You can see corroded steel structures, very large gaps, very large openings in its structure. What was the risk? A large amount of water, rainwater, melted snow, got inside, water which was accumulated at the lower shelter levels, water migrated, radioactive substances also migrated. Sometimes it is practically impossible to follow this migration. We pump water out, but we cannot pump out 100% of water. Even nowadays, there are areas which are not accessible, even nowadays. 20% out of the total number of rooms are not accessible. The basic reason is, first of all, still high radiation levels inside, especially in those rooms where fuel-containing masses are located. Yeah. These rooms are not accessible. Some rooms are blocked by structural remains. Some rooms were concreted. You know that when the sarcophagus was constructed, concrete was just poured, pumped inside. For example, northern area, northern circulating pumps, this very area is concreted. Southern area also is concreted. Diareter stack was concreted. There is no access. So to pump out water completely, it is not possible. So the decision was taken to repair the shelter roof within the stabilization project. These very works were completed in 2008. Nowadays, the shelter roof looks like this. The aim of these very works was to minimize getting all water inside. Yeah. Nowadays we collect it. It goes for reprocessing to special systems. Yeah. But once again, I should stress that we can't pump out water completely. As shelter is not sealed even nowadays. You see, the risks, once again, the risks are still here. You see, nowadays, when 29 years have already passed, nowadays, as well as after the accident, there are no works which are not important, not significant. Each step is prominent because each previous step should ensure the safety environment for the following. The basic task nowadays at the shelter site is to ensure safety. That is the task of the first priority, to ensure safety. Everything is aimed, all our efforts here in Chernobyl are aimed to ensure safety. Safety, first of all, for the personnel, safety for the inhabitants, safety for the environment as a whole. Yeah. Not long ago, 2011, a new system, integrated automated monitoring system, was mounted inside. It's a new equipment. You see, I have mentioned the situation with fuel-containing masses inside. Yeah. Nowadays, the risk of criticality event in fuel-containing masses is extremely low. Yeah, but it's not zero. It's not zero. That's why these very materials, which still represent a risk, long-lived, high-active, they should be continuously monitored. Our task is to monitor their condition and their behavior. And this very system, this very equipment, new, advanced, sophisticated, yeah, has been mounted inside to keep the situation under control. This is the new equipment plus to all those detectors, to all those sensors which were positioned just after the accident. And they are in operation up till now. First of all, we monitor, fix all the basic parameters of fuel-containing masses. We measure temperature, humidity, neutron flux density, the level of gamma radiation, the level of beta radiation, the concentration of aerosols. These are all the basic parameters which are continuously under control. Yeah. In case of any changes, any deviations in, for example, neutron flux density, we have special system. We supply, we feed, yeah, special submixture to decrease, yeah, to decrease the neutron flux density in case of, yeah, any increasing. This very system, this very new equipment allows us to ensure safety, radioactive safety, nuclear safety, seismic safety, fire safety, general industrial safety. So that is the primary task, to ensure safety. Talking about this new project, the new safe confinement project, you see, all those works which were conducted, which have been completed before, they were preparatory works for this new construction. preparatory works which have ensured the infrastructure, first of all. They have ensured the safety environment for this new construction. This very project is extremely important for us. Not only for the Chernobyl site, not only for Ukraine, but for the whole world community. I'm sorry. Включите кондиционер, мы сейчас задохнемся. Там берите дистанционку, включайте. Стоим, наблюдаем. So this very project is extremely important for us, you see, because first of all, the new facility, the new safe confinement, it will be a protection against the still existing risks. You see, it will be not only just a frame, not only a backbone, yeah, which will be placed over the destroyed reactor, over the shelter object. It will be a very great, a huge technological complex. Yeah. So the new safe confinement constructually consists of the arch structure, equipment which will be mounted inside, end walls, two end walls, also a complicated structure, cladding, inside and outside cladding, also multi-layer and multifunctional, very complicated structure, technological building, the construction of which you can see now just in front in the local shelter area. It will be the so-called brain center, yeah, high-tech center, where all the equipment will be mounted, equipment which will support the life of the new safe confinement. The processing sites will be arranged here in this very building. About what processing sites I'm talking about? You see, the first step when the new safe confinement is in place, that is over the shelter, the first step which will be undertaken, it will be dismantling, deconstruction of all those structures which were stabilized. We will deconstruct the roof, northern area, southern area, diameter stack. Well, we will deconstruct western area. And all those structures, they will be fragmented, decontaminated, sorted, and stored inside. Nothing will be removed outside. Everything will be stored inside the new facility. So the arch structure, it's a huge, gigantic structure, the elements of which has completely bolted interconnection. Bolted, yeah. 650,000 bolts were shipped here to the site at 50 tracks. Custom made, specially designed bolts. Yeah. The structure nowadays, which was constructed in two halves, East Arch and West Arch. Nowadays, this steel structure weighs 26,000 tons. Being equipped, the system of main cranes will be mounted inside. The new equipment, advanced, sophisticated equipment, will be mounted inside. This very equipment will be used to complete all the activity inside without involvement of the personnel. This equipment will be shielded, specially shielded, yeah, and it will enable to complete works in the highly contaminated areas. This equipment will be remotely operated. A very complicated system of main cranes, special mobile tool platforms will be mounted inside with various manipulators, such as manipulator arms, concrete crusher, core drills, even 10 tons vacuum cleaner. You see, the more activity inside, the more dust. So even vacuum cleaner will be mounted inside. This very equipment is designed to support the deconstruction of the existing shelter and to support all those operations with nuclear wastes, which are concentrated inside. Nowadays, we cannot start any works with nuclear wastes. We can only monitor their behavior and their condition. Nowadays, there is no safety environment for that. The lifetime for the new structure, for the new facility, the new safe confinement, is supposed to be 100 and more years. So, in its turn, the new safe confinement, it won't be the final step, you see? It won't be. It will be a result of the shelter implementation plan completion, an international program on shelter transformation into environmentally safe site. In its turn, the new safe confinement, the commissioning of the new safe confinement, it will be a start of the activity inside. And in its turn, it should create a time frame to develop, to implement their mitigating strategies and technologies for further treatment of the destroyed reactor. Our task is to ensure this safety environment, to ensure this infrastructure, to ensure this time, to complete all these works. Now you can see the result here at the site. You can see a result of the 5-year physical activity. The arch structure, which was constructed in 2 halves, east and west. The arch itself has passed 6 lifting operations. Nowadays, it is lifted at the design height of 110 meters, being equipped. It will be skidded, it will be moved and placed over the destroyed reactor, over the existing shelter. It will take approximately 1-2 days to place this very structure, which will weigh, being equipped, which will weigh more than 30,000 tons. You see, these very operations, lifting operations, skidding operations, they are completed by international company, Mammoth, and you will see the jacks, these bright red containers. These are jacks, the system of jacks, which is used for lifting operations, for skidding operations. This very company is specialized in lifting of very heavy structures. So all these operations were completed by this company from Holland. So these very works, these very operations, skidding operation, they will take from 1 up to 2 days. The arch should pass the distance of 300 meters. Yeah, this lifting operation, they are shown here at these very pictures. You see the central segment is lifted and side elements were standing into a design position. And these very pictures, these very pictures, they illustrate skidding operations, moving operations. Yeah, these are the so-called push-pull horizontal jacks, which transfer the load from the arch structure to the skidding beams. You see, push-pull jacks. Yeah, they will be used to place the structure over their existing shelter. And commissioning of the facility, of the new safe confinement, is scheduled on the end of 2017, November 2017. A huge project, a unique project. Yes, the structure, the works are unique because they are completed even nowadays in their conditions of ionizing radiation. People still work in the conditions of ionizing radiation. Nowadays, people are the basic concern. We don't want to repeat the situation of 1986, when we got a great number of liquidators. Nowadays, people are suitably equipped. They have protective overalls. They have respiratory means of protection obligatory to avoid any inner contamination. Yeah, they have helmets, gloves, boots, and so on. Time, the duration of work is a very important factor. Yeah, it is strictly regulated by the radiation protection department, because time, the duration of work, means exposure. Time, distance, and shielding. These are the basic three principles how people can be protected against ionizing radiation. So people are the basic concern nowadays. Everything is aimed to protect people who are involved in the works here at the site. Well, that is all. Well, one remark. These very flags, the flags of Poland is here. These very flags, these are flags of donor countries. Countries which donate to the specially established Chernobyl Shelter Fund. Works here at the Chernobyl site, they won't be possible without those experts, this international team which is involved in the works. They won't be possible without international support. You see, the sum of each country contribution you can see here at this very table. It's very important for Ukraine, the support, the assistance of all those countries, which are the members of the donor assembly. Poland is also the member of the donor assembly. So you as taxpayers also are here, also participate in these very works, in these very projects on shelter transformation into environmentally safe site.